Here we're going to introduce op-amp circuit analysis using examples that are building blocks for analog signal processing systems. And we discussed this earlier when we talked about the non-inverting amplifier itself. Now, some of the other basic circuit blocks include the voltage follower, the inverting amplifier, the summer, and the last one we'll discuss is the subtractor. Now, in order to do a basic building block approach to designing circuits using op-amps is to recognize the feedback pattern, and then once you do that, you need to isolate the basic circuit as a building block, and we'll illustrate this with an example. Okay, let's analyze this op-amp. Here we partition the circuit as a source. Recognize that this feedback configuration with this op-amp is a non-inverting amplifier, and the load, and we're asked to find the relationship between the output voltage that's across this load and the input voltage Vs concerning this voltage source. So we want to find the relationship, a mathematical relationship between VO, our output, over our input Vs. First, we recognize that this is a voltage divider, since we know that IP, the current going into the non-inverting input, is equal to 0, since it has infinite input impedance. So all of the current going through R1 is going to R2. So we can use the voltage divider to find VP. Once we know VP, we can find the relationship between VO and Vs. So here, VP using voltage divider is equal to our input source Vs multiplied by a scale factor of R2 divided by R1 plus R2. Okay, so VP divided by Vs is equal to R2 all over R1 plus R2. Now, what's the relationship between VP and VO? Well, we recognize that this configuration is a non-inverting amplifier, and we know that VO divided by VP is equal to 1 plus the feedback resistor R3 all over R4 in this example. Now we note we want VO over Vs. Well, we can manipulate this saying that we already found the relationship between VO over VP and VP over Vs as shown here, and we see the VP's cancel and we get V over Vs. But we have this relationship. Let me highlight that. VP over Vs for this ratio, and then VO over VP is found using this relationship. Now, if you take these two expressions that I just highlighted and just multiply together, we get a relationship between the output voltage and the input voltage, or our source voltage here. In that case, we have VO over Vs. So we have a ratio of VO over VP that's governed by 1 plus R3 over R4. And then we have VP over Vs, which is governed by this relation, in which we use the voltage divider, R2 over R1 plus R2. And that's our relationship between our output voltage and our input voltage. And notice we had two factors concerning the product of what we call Ks using the voltage divider. So here, that's just Ks, and then this relationship we've identified as K amp. And so we replace this circuit with this block diagram here, K amp, our non-inverting amplifier, as K amp, in our voltage divider network here as Ks. and then to get the relationship between Vs and Vo, we multiplied these two diagrams here, these block diagrams, Ks times K amp. In other words, Vo over Vs is just simply the product. This is K amp in this case, and then this term is Ks, to get the relationship between Vo over Vs. So hopefully this example illustrates the process to using the building up block approach to first recognize the feedback pattern and then to isolate the basic circuit as a building block, as we did here.